Hi everyone, my name is Colin. I'm the co-founder for Ecoline Solar. Today, let me start with the or how the current situations right now in the markets or the living environments. We have a lot of basically the heat actually come out from the aircon or any other kind of machinery or equipment. So over here, I'm going to talk about the urban heat island. So normally for the aircon itself, the cooler it is in the room and the hotter this is outside because there will be heat exchanges from cold to hot. Okay, and so in normal areas as what the research are, it had been gone up for about 7 degrees Celsius over the urban or the metropolitan areas versus the rural area. So what's the contributions are? Basically, they are all these 50% were from the actually vegetations and all these other material surface, and the other 50% will be from the air cons, appliances, transportations. Okay, so this is what Singapore currently right now, as what you can see, is the colors over here. The all the areas down here is getting hotter and hotter, and not much of a cooling area. Even the coolest part is about 24 degrees Celsius. And these effects will be for the thermal comfort. That means will be poor city livability, and also human performance with productivity. So people getting too hot, the working morale will be lower, and that of course intensities of the extreme rainfall as well as the heat related fatality. So over in the research that the increase in temperatures for Singapore has been almost double, and then the latest UN research also indicates that the global warming can go pretty high. Okay, so for aircon itself, so far there is no change in the technology. Even there is, it will be very minimum, the improvements, but not the labs. Of course, over here we can see over here the increasing of the installations from current existing 1 billion units of single rooms installations to 4.5 billion projected in 2050. That means to say that the heat that going to be disposed out or the rejected out to the ozone is going to be very huge. Okay, this is also one of the article actually has been or published in the Straits Times, where the SMU's professors has been talking about we try to actually reduce the heat rejection. For instance, like using the larger part space, green roof, and so on and so forth. Of course, if we can have a better technology such as the solar thermal hybrid air cons, that to reduce the waste heat input into the urban climates. Okay. So now we have a new approach to tackle all this UHI. Okay. Reducing heat loads by the solar thermal cooling. So this is what. Okay. For us, we will be looking into recycling, reuse, and reduce of the heat for more cooling city. So for instance, over here, example, like if let's say District 19, if let's say we can using this or STC, which is the we will be able to reduce 1 to 2 degrees for the outdoor ambient. So you can the neighborhood will be much more cooler. Okay, so well, what about Ecoline? We have been doing this heat recovery since 2003, and we have installed the world first DX solar thermal air conditioning system since 2006. And we are the only DX systems that's certified by the HGBC as green products. And 2 years back, we actually have the IES Prestige Engineering Achievement Award, as well as the ASEAN Outstanding Awards. So how our systems work? As well, you can see over here, for conventional systems, normally they run through the compressor and then or reach the desired temperatures and pressure, or subsequently go down to the condenser coil actually to reject the heat out. So this hot air that's rejected will be around about 45 degrees C. So that will be actually or contribute a lot of waste heat into the environment. So okay, for us, for the Ecoline solar thermal aircon, we actually use a solar collector basically to harness the heat from the ambient as well from the rejected heats. That is why we are doing a recycling of heat, and then subsequently go to the compressor to compress and superheat up to the desired temperature, and then to the condenser coils and reject the heat out. By then, for this heat that rejected out, basically for the temperature is much as low as about 31 degrees Celsius. Okay. So that will be contribute lesser to the urban heat island effect. Okay, so basically, sorry, okay. So these are some of the solutions provider we provide to the indoor farming, as well as the DX for the United Nations, and also the data centers racking, because all these sprays or the applications what they have used, they have a lot of heat over there, which that we allows us to harness more to actually do the recycling of heat, rather than let all this heat actually dispose up to the environment. Okay, so these are some of our installations. Almost about 1,500 of systems has been installed currently right now in Asia Pacific. And we are actually gaining from there the energy savings from as high as up to about 55%. And these are some of the customers and also our collaboration partners, and as well as the R&D people. So for this is one of our projects that what we have done in 2017, and we actually help them to actually achieve the Platinum Award by using our aircons. And this one is what we have been tested over the heat rejected from the other systems is about 35 degrees Celsius and can go as high as up to about 45 degrees. Whereas our systems, the maximum we can go up is around 31 degrees Celsius. So this actually have a 4 degrees Celsius is a lot lesser to the heat rejected out to the environment. And these are some of our happy customers. And this will be our range of products. It's actually quite similar to what any other kind of DX systems can provide. Okay, so in summary, these are the contributions to what our systems can do to contribute to the environment. And that's all for my presentation. Thank you.
Good afternoon. I'm the CEO of Lumani Private Limited. I'm Chris Hong. Very happy to talk about sustainable problems that we are facing. Well, usually when we say sustainability, we are talking about the environment, not about other things. But to do that, we actually have to do more than that. The problem we have is that every time we want to do the project, then the OBMS is there, and it's hard. It's hard for us to. It becomes the bottleneck of everything we do, as the new technology is incompatible with the OBMS. So what we do is that we need to put related technologies connected to the old system. Technical, to get green, you need to add sensors and control to various equipment. They are usually separate systems, and expensive hardware and labor are usually repeated investment. Even you succeed to install, then the user probably don't want to use it after they get the green mark. So what we do is that you have to make user happy to use it. And if there are too many new things for them to learn and too many extra work to do, they don't want it. So especially when they have a lot of things to do without making sure that energy and money are saved, it's not good for them. So how do we build sustainability for buildings? You have to do is that you have sustainable system and sustainable user, sustainable company to form the sustainable building. First, we have to make the system affordable. It should be cost effective. Self-sustainable means that it would generate extra value, and services to have a revenue to pay off the system itself. And low maintenance means that people don't have to spend much care to maintain it. And happy occupants, it should be easy, healthy, comfortable, and even fun to use. And when you have the happy people and you have the happy employers, and to make the environment data-oriented and flexible workspace that we can use the data to improve the performance. And so that we can attract talents to join the company and make high productivity. So the building can be efficient enough for energy consumption and to get the green mark, and at last the property value goes up. In order to solve the problems that given that we have a legacy BMS, then we must have something to talk to it. For example, a protocol converter, so we can add extra features to talk to the BMS, and even give it a fancy web-based dashboard, so that we can get the legacy BMS into an AI-based smart building system. And that can save 30–40% of energy without going to analytics. And we also got additional information about occupancy, temperature, humidity, IAQ, energy consumption, even video analytics, reduce FM power by half. And we have a comprehensive dashboard to have a deeper understanding of the building. And the FM people also get the alert on the go, so they even they are offsite, they can get the alert from the user for something faulty. About sustainable users. Well, the users are sustainable because they are happy and healthy to use the system. So the method is that we enhance the correlation between the space and the occupants through our system, which is intelligent, autonomous. Just like a driverless car, sometimes you want it to be automatic, but sometimes you really want to drive it. The building system is the same. You don't always make it autonomous, but sometimes you really want to override the system by manual control. So we have our system to make the transition very smooth. And it also has to be comfortable and healthy so that user will keep using it. The feedback from the system to the user is also very important. If the users don't know what's happening or what they have been participating for the green building, they are not interested in using it anymore. And for the space operator, high operation efficiency and data-oriented flexible workplace is also very important. So they can collect the data of the ambience and the users to improve the performance of the building. How do we make a sustainable company inside a building? Well, we do it through a lot of data collected by the sensors like IAQ, which is an indoor air quality, motion tracking sensor, and also temperature and humidity sensor, and also some controllers like smart door lock, lighting control, and even aircon and infrared control. And we use a method of an app called a companion app for the occupants, which is to check in for the user to get the service or to use the space or even the devices. All the behavior of the occupant will be recorded on the system. We have all the data from the hardware, the ambience, and also the user, so we can have a thorough understanding of the environment. So how should the sustainable building be? It should be smart. We use our autonomous zone control for the lights and aircon, and get the information of the ambient by the sensors, and each zone is operating independently to get the best results. And it should be comprehensive. One single platform for all kinds of application, like lighting, energy saving, access control. And the building must be green and streamlined. SLEB solution. It should be 30 to 40 saving on energy, reduce half of the FM work, and increase the productivity and the space utilization. I'm talking about our key technology to fulfill those requirements. We have patented the algorithm for long-term and short-term prediction. Usually, the AI system for built environment is long-term prediction. They collected the data for example, 1 week, then they provide the analytics, then have the result. For example, turn on the aircon at 9 a.m. before people coming in. Then, well, in that kind of a situation, if people just don't show up, the company go out for outing, then the system would just run and waste a lot of energy that day. In our design, we use a short-term prediction as well. If we don't see the people show up, sensor would just kick in to take over the long-term prediction and turn the system off, or at least make the system on the standby level until the people come in. And we also use a QR code operation versus autonomous operation to switch between a manual and autonomous control. So when people like to override the cloud operation, they can just use their app and change the scene. Lighting control is the first development of our company. We started from there. It's a backbone of our system, as inside the building, lights is everywhere. So we use the sensors of the light to detect if there are activity, and also learn the occupancy level there. And now we use circadian lights to make people even more comfortable in that environment. As a blue light is bioactive, and yellowish light is more relaxing. So the right color temperature at the right time is very important for the occupant to feel comfortable, and also maintain their health. And we are the only solution that can do the occupant wellness while we are saving energy, because our LSM algorithm would just detect the occupancy level in the zone and decide what kind of a thing to play to save energy. LumaZone is not only a platform for lighting, but also for many other things. We have air quality detection. We have HVAC management, all according to the data that we collect from the zone. HVAC system is the most power consuming equipment inside the building. Now we are going to talk about VAV, how we save energy there. In the typical zone, typical space with 4 zones, you have some zone with people, some zone without people. Take this for example, the red zone is empty, but it still blow air, cold air there, and the valve is open like 60%. It's a waste there. So what can we do there? We just use a demand-oriented algorithm by the motion and CO2 level to decide if the zone is occupied. Then we use remote sensor to calibrate the correct temperature setting. As the air, usually VAV's temperature sensor is in the air intake, and it's usually hotter, 1 or 2 degrees higher than the temperature with the occupants. So it's actually a waste. If the sensor is reach the set point, it will be too cold for the occupants. So we can use a remote sensor to calibrate the temperature, and you can save at least 10% there. And we can also make the balance between the air quality and the energy consumption by detecting the right temperature, right CO2 level to make a compromise on the air quality. We provide a dashboard and heat map. This is very important feedback to the occupants that they can have the understanding of what's happening in the space they reside. We provide air quality heat map and as well as occupancy level heat map. So they not only the occupants but also the management people can see how their building is used. We have a method to let the occupant to participate the building activities more. This is a companion app that they can use the app to scan the QR code when they try to, for example, use a space, book a meeting room, or order services like order a coffee, or just use a projector. And all the behavior will be recorded on the system, so we know what's going on there. This is the spaces inside that it records not only the ambient data, but also the occupants' behavior, who is there and do what and when. The comprehensive occupant data analytics have all the data from the sensors and as well as from the occupants. So we have a thorough understanding of what's going on in the building and make the right decision to improve, to get the higher performance. Here is our measured data about our project. Cable Bay Tower is our biggest project in Singapore. it's the first building to get the Green Mark Platinum Zero Energy building. We improved the lights from 11 watts per square meter down to 3.3 watt per square meter. From LED to LED, we save 13.4% at peak hours. It's recorded from 8 a.m. to 8 p.m. If we count the consumption from the 7 to 12 p.m. to 12 a.m., then that would be over 30% safe. This is what we save on the split type aircon in our office. It's only one zone, so it has no effect on the zoning, no save on zoning. It's just purely the temperature calibration and humidity control. You can tell that the dotted line are the original aircon control, and the yellow and blue lines are our LumaZone control. You can tell that it holds the temperature to 25 more closely than the original control. Therefore, it can save between 10 to 20%. These are success stories of our sites. We work with mostly the government, co-share spaces, and also the school over Singapore and Taiwan. Conclusion: the true sustainability system has to pay itself on extra value and passive income. We can not only talk about the energy ROI, because the baseline of the new technology like LED and inverter aircon, the performance is higher and higher. A baseline is smaller and smaller. So the baseline itself cannot pay off the investment of the system. Users should be happy and enjoying the system, and user cannot abandon the system after getting the green mark. If they are feeling uncomfortable or getting unhealthy, then they will definitely abandon the system. And when we build the system, it actually consumes a lot of energy, and it would be more harmful to our planet. Happier and employers through a total data management to create green, smart, and flexible workplace, and attract the talents and increase the productivity. At the end, well, people have to make money. So we should combine sustainability and profitability all together. Building with a vision, facilities, happy occupants, and the building owner must have to enjoy a higher property values, so they would invest in sustainability solutions. So when people benefit from being green, it's truly sustainable. Thank you.
Good afternoon. Well, almost good evening now, but thank you for accompanying us in this session. I'm going to speak about marine renewable energy. And this is something which is not necessarily always linked with the built environment, but I think it's worthwhile talking about it because we do have coasts and lots of islands in this region that could benefit from sustainable development. So in this short presentation, we will look through some of these sustainable integrated developments for coastal island and maritime energy ecosystems. OceanPixel has been doing a lot of work in making marine renewable energy a reality the past 6 years, being a startup based out of Singapore, coming out of Nanyang Technological University. We leverage a suitability analytics engine licensed from the university, from the Energy Research Institute at NTU, to help more and more projects that involve marine renewable energy in the region. So why do we do that? Andy already mentioned the significance of oceans, but just to reiterate, 70% of the Earth's surface is ocean, and we have 70% of the oxygen on Earth actually being produced by oceans, and 40% of the world's population live within 100 kilometers of a coast. 10% of the world's population depend on fishing. So this is sort of something that we should not neglect. And there are metrics associated with the makings of a sustainable marine ecosystem. And this includes, reduced greenhouse gas footprints, efficient and sustainable use of marine space, minimal impact on the environment, and of course, having continued monitoring and regulation of interactions between humans and the environment. What means would we need to have to achieve sustainability in the marine ecosystems? So here are some icons with their respective means. But I want to focus on the green energy production, which is an enabler to maybe a lot, if not all, of these means and end outcomes. So linking sustainability, electrification, which is primarily energy, and digitalization has been a thrust that we've been having in these past years, primarily for our work in this Southeast Asian region. Why is that? Because electrification is more than just electricity supply. Really, you can look at electrification of end-use services like transportation, which means vessels and ports, processes, and therefore automation, for water production, for instance, for logistics, energy storage systems as well, aquaculture, ice making, and others. So islands typically have end-use services that are not necessarily linked just to electricity, but also other energy end-use. Sustainable integrated development for islands and coasts need to be done holistically. And even though renewable energy might be one of those main things that could be featured on a sustainable island project, it needs to make sense from a holistic perspective as to what end use you have for the electricity, be it for business, for economic use, and maybe other sustainable initiatives. So these are just some of the potential projects that you could have linked with energy production. On the lower left of this slide, you will see a traditional floating power barge in the Philippines. And that power barge is a diesel or coal-fired power barge. You can imagine how that contrasts to a renewable energy floating platform system or a renewable energy island system. So this transition is happening now. So there is another simple term that describes the link up of all these initiatives, and that's called the blue economy. It simply looks at the marine and coastal environments and ecosystems, not just sort of in an environmental sense, but the ecosystems of humans, businesses, technology, right? And even political and legal aspects. So the blue economy is one way to describe what I've been speaking about this past few slides. And marine renewable energy, which is renewable energy produced in marine space or using marine resources, is an enabler for the blue economy. Now, many people get confused between marine renewables and ocean renewables. Are they the same? Ocean renewable energy is a subset of marine renewables. whereas marine renewables includes things like offshore wind and marine floating solar, marine biomass. Ocean renewables primarily looks at these 5 different resources: currents, tides, waves, thermal gradients, and salinity gradients. Yes, even the saltiness of the water, the difference in the saltiness of water can be used to generate electricity, which is what some of our desalination plants in Singapore already do to improve the energy efficiency of the water production. So, but having the resource is not enough. You need to have technologies that harness this resource as well. So this is a scale of technology readiness level from 1 to 9 used by NASA, already also adopted by IRENA and all the other maybe agencies that look at technologies in terms of maturity. So 1 will be basic principles being observed, 9 being commercially available. Offshore wind is already commercially available. Marine floating solar, close second to be pre-commercial scale. Tidal in-stream energy to be in the pre-commercial to commercial scale. Wave energy converters picking up with sort of field testing and demonstration projects. But what this says is that even though some technologies may not be yet that ready, commercially speaking, they can be deployed in conjunction with other systems. So for Southeast Asia, marine-related renewable energy options do exist, and there's very high chance of feasibility for marine floating solar and offshore wind. And these other resources which are available in the region, the resource is high and the technology readiness level is appropriate. Now, for tidal barrages, present technologies still need higher than 4-meter tidal range to be economically viable, and there's an issue of environmental impact for large dams of water in bay areas, so people are moving away from this. So for salinity gradient, it's good for energy recovery, but too expensive on its own without any co-application. For tidal currents, I may just highlight that the resource itself is predictable to a 95% degree of accuracy every 30 minutes for the next 18.6 years, even if I just do 3 months worth of resource investigation. Now, you don't get that with any other resource, renewable energy resource. For global initiatives around the world, other people already have locations where they do have deployments, commercial pilots, demonstrators, etc. Sadly, in this region, in Southeast Asia, we only have a few things happening, mostly in research and development. We want to change that. The vision would be to have sustainable islands using sustainable energy, maybe 100% run on renewables. Is that possible? Well, yes, in the north of Scotland, they're already doing it. Since 2014, they have electricity supplied by more than 100% by renewable energy, including marine renewable energy options. Now, for developing countries, however, you have a range of activities that are happening here, and I just want to show you a spectrum of what the technologies are since 2003, how they've grown, and what they compare and contrast would be in terms of suitable technologies in this region versus technologies in, let's say, Europe and North America. The Westerners have a more of an oil and gas mindset, whereas Southeast Asia more or less has a, hate to say this, like an ulu mindset, but a smaller sort of kampung type of mindset, which leads us to develop appropriate technologies for our ecosystems. Not necessarily bad, but they might not be that big to begin with. We can have small but many rather than big chunky machines, which you need certain water depths, which you need certain vessels to deploy. So configurations for ocean energy systems for at least tidal in-stream energy can also range from jetty-based fixed structure mounted to floating systems to semi-submerged or neutrally buoyant systems to seabed mounted systems. And you can have a combination of which in between as well. So what have we done to help this sector? I talk about suitability analytics because that's our bread and butter. So in Singapore, on this left hand of the slide, we know where there are strong currents. We know what the currents timings are. We know what kind of energy can be extracted in these currents. And we kind of know what to fit in terms of technology, in terms of, to harness them. Similarly, you can apply the same suitability analytics for countries like the Philippines or other locations, and you can use a lot of the data intelligently so that you can generate insights, you can score things. And if you were a project developer, you might as well look at, okay, how much money can I make if I look at this site and that technology? Or could you tell me what is the best site technology match for my project? Sure. So examples of case studies, I'll show you three. One is this cushion roller technology at Tanah Ferry Terminal. You know, harnessing energy that's low wave. Yes, Singapore has waves, but it's low. What does that mean then? Well, if you can't harness high waves, then can you harness low waves economically, right? With a cheaper device? And the answer is yes, you can. So, and this is what has been embarked on by Maritime Port Authority, working with NTU and the Singapore Cruise Center, equipped with the suitability analytics outputs that we are able to give. So more than that, we've also looked at uh, projects in off-grid islands that use diesel, and we've deployed a pilot project to look at tidal energy to hybridize this off-grid operation of mangrove wood chips. And they've connected it to shore using their own know-how, local barge, local connection to shore using not a submerged cable, but through the air. Interesting. We also provide insights on, let's say, what the techno-economics might be, you know, and what combinations of renewable energy systems would lead to maybe best bang for buck. So in Singapore, we've also done a project. You may note that this image here that you see is deployed off near the Sentosa Boardwalk, but that was in 2018, and then it was removed after that for recommissioning somewhere else. You can see that this floating platform was built locally as well. This floating platform would have been equipped with a tidal turbine that would be submerged in the water, have the flow being harnessed by this simple propeller, and you can generate electricity from it. You can combine it with solar, combine it with diesel, and you know, with the tides that are predictable, you might have a better energy use case as well, especially for remote communities in the region. So that being said, we could actually look at number of pilot projects, right, that are enabled by marine renewable energy. And that goes beyond just electricity, but you can look at vessels and water and food. So in summary, we have options that do exist, marine renewable energy options that exist. And the markets that this could serve would be green marine and maritime ecosystems, green vessels, green ports, electrification of a suite of applications, transport, food, and water. And we need a progressive development towards this blue economy, leveraging this ecosystem which countries have, developing local capability, proceeding with demonstration and pilot projects, and hybridizing them would be the key to success. So as OceanPixel, we not only work with renewable energy data sets, but actually with sectoral data sets depending on the client and customer segments, right? The blue economy presents marine data intelligence as a key commodity, and those that know how to leverage marine data can provide services, which is a $140 billion market globally. So just in the Asia Pacific and specific areas of that, OceanPixel's market is already $1 billion, right? This digital ecosystem that can generate intelligent insights helps our clients reduce costs by 30 to 50% because they make decisions smarter. Our traction so far the past 6 years has led us to over 50 engagements worldwide. And a lot of it is anchored in Southeast Asia, as you can see on this map. And we have industry sectors primarily in the first vertical or pillar on the left here, but we are expanding to the rest. In the future, we may not just look at marine data anymore. Could we look at habitable environments, smart city data, building data, farming data, right? And other things. So currently, we are actually in the midst of our investment round to raise 2.5 million to grow our company in terms of market from where we are to slightly below a million to 10 million and $100 million revenue in 6 years. So the team, as you can see here, is a range of people working Singapore, Philippines, Australia, and our journey has taken us to a lot of strategic partnerships, not just with project developers, but with technology providers as well. And we have currently been developing core IP. And if you want to link up and know more, my email is seen on this slide. And I thank you very much. Hoping to hear from you guys soon.